Hello, this video is the second and the final part on voting. It's going to be based on sections 5 and 6 in chapter 3 in networks, crowds, and markets. And today I'm going to talk about two mathematical results. They're actually theorems. So one's called Arrow's impossibility theorem, and the other one is called the median voter theorem. And although they're purely formal mathematical results, they have some very interesting implications to real world situations. But before we talk about these two results, let's do a quick recap of what kind of questions we're dealing with. So here's the idea. We live in a framework in which there is a finite set of alternatives labeled by capital letters and a finite set of agents. Each of those agents has complete and transitive preferences over the alternatives, and somehow these agents need to decide on a common group ranking of these alternatives, which is based off the original preferences of each participant in the group. So the goal is to generate a group preference relationship over the alternatives from individual preference relationships. And any procedure, any rule that generates such a group ranking is called a voting system. So let's focus on properties of voting systems. If we deal with voting systems, the best thing to think about is which procedure should we choose to make a particular group decision. Like, for instance, imagine a situation when you and your friends share a car and you need to decide which restaurant to go out to have lunch to. And each of you might potentially prefer different places, but ultimately you need to settle down on a single place. And how would you go about deciding which place you're going to go to? This is the kind of situations we're dealing with. Which rule to use to aggregate individual preferences? And so when aggregating individual preferences, we'll have the following desirable properties. We would like the following things to work no matter what individual preferences are. First of all, we would want completeness and transitivity of a group ranking. Basically, no matter what individual preferences we're starting with, we want this rule to allow us to select a winner anytime for any sort of preferences. Second thing that we want from the voting system is unanimity. That means that if all agents prefer alternative X to alternative Y, then in the group ranking, that preference has to be preserved. X should still be preferred to Y. And finally, we would like a certain property that's called independence of irrelevant alternatives. And that means that if the voting procedure, the voting system, generates a preference of X over Y in a set of alternatives that doesn't contain Z, then X should still be preferred to Y when Z is added. So for example, if you prefer Josiah's to the dining hall, then you should still prefer Josiah's to the dining hall even when Subway is added to consideration. So adding new alternatives to consideration shouldn't change the order of preferences of the alternatives that were already considered. Okay, and so it seems reasonable to focus on these three conditions. We care about transitivity, because completeness we usually get for free. Completeness isn't usually a problem. So we care about transitive preferences, we care about unanimity whenever it applies, and independence of relevant alternatives. Of the two kinds of voting systems that we looked at in the previous video, we know that the majority rule violates transitivity. Recall the example from the previous video when three individuals choose over three alternatives, and each alternative beats another in a pairwise comparison, and so transitivity is violated. The group ranking has a cycle in it. And so that's a problem with the majority rule. It does not satisfy transitivity in all cases. What about a voting system that does not satisfy unanimity? Well, we really need unanimity just to exclude any voting system that uses a simple rule such as always pick the same alternative. So we care about unanimity if, for instance, um, everybody prefers Josiah's over the dining hall, so the group ranking that says always go to the dining hall then shouldn't be used. And finally, with independence of relevant alternatives, in the previous video, I looked at the border count, a rule that assigns points to each alternative depending on its order in an individual's ranking. And so that rule violates independence of irrelevant alternatives. Again, go back to the previous video and recall that in the example we looked at, the movie Citizen Kane in a pairwise comparison defeats The Godfather, but once we throw Pulp Fiction into the story, Godfather defeats Citizen Kane because some people would place Pulp Fiction as second, and so Citizen Kane would get less points than if compared face to face with The Godfather. So positional voting like border count suffers from irrelevant alternatives. You throw in extra alternatives and the outcome of the comparison, the group ranking, may be altered. So X is preferred to Y, but once Z is present, Y can be preferred to X. So that's a problem. And so the impossibility theorem simply says that you can't really get all these three properties in a voting system unless that voting system is a dictatorship. So here's how it's formulated. If there are at least three alternatives, then any voting system that satisfies transitivity, unanimity, and independence of irrelevant alternatives must correspond to dictatorship by one individual. How to understand it? One way to understand it is as follows. If you don't want to violate the three conditions, just let one person call the shots. So, for instance, in our class of 18 students, there are 18 possible group rankings based off each individual in the class. But basically, if you want 1 through 3 to hold, just make the group ranking match one person's ranking from the set of agents. If you don't do that, then sometimes something can be violated. In the second alternative, if you don't want a dictatorship, at least one of conditions may be violated, and so you need to think about what are you willing to sacrifice? Are you willing to sacrifice transitivity? Then go ahead and use the majority rule. Are you willing to sacrifice independence of relevant alternatives? Then go ahead and use border count. Or if you don't care about unanimity, use a very simple rule like pick alternative X no matter what. So that's sort of bad news, but so far we've dealt with a very general framework. And the general framework that we've dealt with considered any kind of original preferences that you can imagine. So in principle, an agent can rank a set of alternatives in any particular order. And because we want a rule that generates a ranking that satisfies all the conditions, no matter what the original agent's preferences are, sometimes agents can have such distinct preferences that no rule works great. And that is the essence of the impossibility theorem. But in certain cases, we can make our life easier by restricting the set of possible preferences by looking at what's called single-picked preferences. And I'm going to give you an example that you're familiar with. In some cases, alternatives can be ordered along the spectrum, and think about the political spectrum. For example, if you were to decide what is your favorite candidate, you can always think about, well, the left-right spectrum, with the left being more egalitarian or more socialist, depending on how you treat it, and the right being more libertarian or more free market or whatever. So there is then this natural spectrum along which the candidate's position can be ranked. And I actually don't want to deal with political figures. Instead, I'm going to look at a very similar example that'll have to do with political parties. And so here's the example. If you know, Puerto Rico is a US territory, which is not exactly a state, but not exactly an independent country. So it's somewhere in between. And the political parties in Puerto Rico advocate for three different alternatives. There is a party that advocates for statehood, that says that Puerto Rico has to become a state and get all the rights and responsibilities of a US state. There is a second political party that advocates for the current status quo, or maybe with some alterations to it. And so that state of affairs is called the Commonwealth, where Puerto Rico is associated with the United States, but has some degree of independence. And there is a party that advocates for complete independence from the United States. So these people would want Puerto Rico to be an independent country. And so naturally, these three choices, these three alternatives can be ordered along a spectrum where on the left will be alternatives with closer proximity to the United States, less independent. On the right will be more independent, farther from the United States. And so when we talk about single-picked preferences, the condition is that every voter, every agent who has to make a decision needs to pick a favorite alternative, and all other alternatives will be ranked by its proximity to the favorite. So for example, what is allowed under single-picked preferences? For once, you can say, well, if somebody likes statehood, then the next closest to statehood is Commonwealth, and the second closest is independence, so statehood should be preferred to Commonwealth to independence. Or if somebody likes Commonwealth, well, it doesn't really matter, but independence and statehood should come second and third. What is not allowed under the single-picked preferences condition is to like statehood and then to put independence as second best and Commonwealth as the third best, because independence on the spectrum is farther away from statehood than Commonwealth is. So if you like statehood, then Commonwealth should be preferred to independence. If you like independence, then Commonwealth should be preferred to statehood. And graphically, we can depict each of these three kinds of preferences as follows. Statehood first, Commonwealth second, independence third. So top rank, second best, third best. You can see that there is a single peak on this graph. Commonwealth first, independence second, statehood third. Commonwealth is the top choice. Independence is the second best. Statehood is the third best. Again, there is a single peak on the graph. What's not allowed is to have more than one peak. For example, statehood is better than independence, better than Commonwealth, gives you two peaks. One peak at statehood and one peak at independence. So if we restrict our attention to preferences of the first two kind, but not the second kind, then we can say more than what the arrows impossibility theorem says. To do so, the next step for us is to align voters according to their favorite alternative. And so in this example here, I'm going to have 9 voters total, just because it's easier to deal with smaller numbers. And I'm going to say, okay, let's suppose that 2 voters have statehood as their top pick, 4 voters have Commonwealth as their top pick, and 3 voters have independence as their top pick. Let's consider the median voter. Who is the voter that has exactly 50% of the population, 50% of the group to the left and 50% to the right? In this example, the median voter would be somebody who prefers Commonwealth, because if we align voters one by one by the line, we have 9 total, so the 5th voter somewhere in the middle will be the median voter, with 4 voters staying on the left of that voter and 4 voters having their top picks on the right. So in this example, the median voter would prefer Commonwealth. Let me give you a different example so that you don't think that the median voter is always has the middle pick as the top choice. Here's a second example. Still, the number of voters is the same, 9, but now 6 voters choose statehood, 1 voter chooses Commonwealth, and 2 voters choose independence. In this case, the 5th voter the voters such that 4 are to the left and 4 are to the right will still prefer statehood. So the median voter here prefers statehood. And the next thing that I'm going to do is I'm going to formulate the median voter theorem, which says two things. First, with single-peaked preferences, majority rule generates a transitive group preference. That was important because under general conditions, with any possible ordinal preferences, majority rule may fail to generate a transitive group preference. Basically, because we're not allowing preferences such as statehood is the first, independence is the second, and commonwealth is the third, we get rid of this problem where pairwise comparisons will generate the cycle among these three alternatives. The second part of the median voter theorem statement is that the median voter's favorite alternative would be the top choice according to these group preferences. So if the median voter prefers Commonwealth, then we can go ahead and safely use the majority rule and Commonwealth will win. If the median voter prefers statehood, then statehood will win by pairwise comparisons. And you can go ahead and Google it, but Puerto Rico holds a referendum every now and then trying to figure out how this territory, how this country should proceed, whether it should become a state, whether it should become independent, or stay more or less the way it is. And it's very hard to decide because it's very hard to even agree on the procedure that should generate the outcome, not to say to make that outcome binding. But the problem is present. Every voting system that you can potentially think about might sometimes fail. And so in the example of real Puerto Rico, I'm not sure that the preferences of the voters are necessarily single-picked. It could be that some independents, some people who side with the Independence Party might pick statehood over Commonwealth as their second choice. Or some people who side with statehood might pick independence over Commonwealth as their second choice. So if you're really interested in that story, I think it's more complicated than that. What is simple is if preferences were single-picked, whoever the median voter prefers should potentially be the outcome of a referendum which will ask three questions. Statehood versus Commonwealth, what do you like better? Commonwealth versus independence, what do you like better? Statehood versus independence, what do you like better? That should be it then. Okay, thank you very much, and let me know if everything makes sense or if you have any additional questions. Thank you.